14-1, Part 2, Human Pedigrees. So a pedigree is kind of like a family tree, and it shows the relationships within a family. And what it mainly is for is to show whether or not a trait is absent or present. And it shows the relationship between parents, siblings, and offsprings. So you need to be able to read a pedigree, especially, and be able to make a pedigree. So let's look at the symbols that a pedigree has on it. First of all, you have a circle and you have a squares. The circles represent females, the squares represent males. The horizontal line that connects a circle and a square indicate who the parents are, or the mating pair. Vertical lines that drop down from those horizontal lines represent the offspring. So in this picture here, number 1 and 2 would be the parents. The offspring would be number 1, number 3, number 5, and number 8. Roman numerals indicate the generation. Arabic numbers, like 1, 2, 3, 4, will indicate the individuals. So individual 1, that is in generation 2, is a male. So the trait that's being studied, or the person that has the trait, would be shaded. So in this case, we have in first generation, the male has the trait. In the second generation, there are 2 females with the trait and 1 male. And then in the third generation, there are 2 females and 1 male that have it. Now, you don't see it on this pedigree, but sometimes you might see where a circle or a square is half shaded in. And that would be a person that has the gene but does not express the trait. Okay. So they have the gene, but they don't necessarily have the disease or express the phenotype, the trait. Okay, so on your notes, I put down this pedigree, and I want you to go ahead and analyze it. So how many generations are shown in this pedigree? You should have put down 4. How many offspring did the parents in the first generation have? Let's see, they had 1, 2, 3, they had 4 offspring. What does the square in generation 1 stand for? It's a male. And then why is he half shaded? Because he is a carrier of the trait. Which dog was the first in the family to be short? It'd be the first animal in generation 2, and it was a male. It says a female dog from generation 3 has 4 puppies. How many of these display or carry the short trait? So how many are half shaded? That's right, there's 2. How many of the offspring are short? The offspring from the female here, she has 1 short puppy. Okay, here's a chicken pedigree I would like you to look at. How many mating pairs are shown on this pedigree? So you're counting horizontal lines. So you got 1, 2, 3, 4, 5, 6, and then that's it. So there's 6. How many on this pedigree are females? So you count the circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many are male? You count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are males. How many generations are there? You're correct if you said 4. How many of the roosters have the trait? I see 3. So you're looking for the darkly shaded squares. How many of them don't have the trait of the males? You're looking for the white squares. 1, 2, 3, 4, 5, 6, 7 of them. With the females, how many have the trait? 1, 2, 3, 4, 5, 6, 7 of them. How many of the females do not have the trait? 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5. Females don't have it. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 females, no. 8 females did have it. Did any inbreeding occur? First of all, inbreeding is when you mate animals that are related to each other already. So for instance, cousins or brother and sister or something like that. So there was inbreeding. It was in the 3rd generation, and the individual was 1, 2, 3, 4. The 6th, and between the 6th and 7th individual, they're cousins. It said if your answer was yes, what was the result? All of their offspring had the trait. So if it was a good trait, that's a good thing. If it's a bad trait, then that's not such a good thing. Now you should be able to look at a human pedigree and determine whether or not it's a dominant or recessive trait, an autosomal, or a sex-linked trait. So how would you do that? Well, first of all, if it's an autosomal dominant trait, not sex-linked, just dominant, one of the things is that males and females will have it, and probably with about the same frequency. And usually it won't skip a generation. You'll see it in every generation. And then it says transmission will stop after a generation in which no one is affected. So in this case here, it'll probably stop after this 3rd generation here because none of them have the trait. Now as far as a recessive trait, you got males and females that can be affected. It can skip generations. So you see one up here where the parents don't have it and then one of their children do. Okay. Sex-linked, I'm not going to show you a picture of, but that's easy to tell because it's going to be mostly males. And it can skip generations.